And we should be live. Welcome everybody to another live stream repair. We've got a whopping 5 HomePods that have been mailed into us today for various repairs. We've pretty much got the full spectrum of everything that could go wrong that you can repair on these HomePods with us today. First one comes from James with Death Farts. And next up we've got John's with No Power. Then we'll move on to Chris's that doesn't have any bass, and we'll wrap up with 2 HomePods from Nathan, both of which have no power as well. So, without further delay, let's go ahead and open everything up and start with James' HomePod here with Death Farts. Here we go. And looks like we've got some goodies in here too. Ooh, what is this? We got a note in here too, so let's see. Hello, Nick. Please find my HomePod enclosed. Makes a loud, crazy sound every 5 minutes. I have also included a gift. An electric screwdriver. Might come in handy for disassembly. Give it a try. It has torque settings for assembly too. Get one of those magnetizers to energize the tips. Oh, I happen to have one of those magnetizers. I just got my hands on one. So, let's take a look at this screwdriver really quick. Wow. That looks really nice. I don't know what to say, James. That is just really nice. Oh, let me change the name here. It's actually Jim. Thank you, Jim. Or James. Whoever you are. That is much appreciated. Wow. Oh. Oh. Amazing. This is gonna really save our hands. I can't thank you enough, man. Let's see here. It doesn't look like it comes with a T6, but I think... Let's see here. Okay, I'm gonna have to find some sort of an adapter so that I can actually use the T6 Torx size that these HomePods use. Once I get an adapter, I should be able to use the T6, or actually I should be able to find a T6, a regular sized T6 bit, and then we can give this a try. I cannot wait. Oh, and you know it's a modern electronic when it's got USB-C on it. That is incredible. Thank you, Jim. Oh, thank you so much. That is really nice. And it comes in this sweet carrying case too. Alright, we're going to have to find a T6 bit that'll fit into that before we can use it. In the meantime, let's jump into James or Jim's HomePod here. And we're going to go ahead and connect it to power and check our symptoms. If it's got death farts, then what I'm expecting is when we power it on and we wake it up for the first time, we should hear a fairly loud popping sound. And then with the amplifier on, we should hear another popping sound when we unplug it from the power. The louder the pop, typically the more DC you have being produced by the amplifier and being sent into the subwoofer. Alright, hold on. Let's make sure that doesn't kill our cameras here. There we go. Okay. So as I was saying, the louder the pop, most likely the more DC voltage the amp is sending into the subwoofer. The reason why that happens and why you don't want it is there are a few filtering capacitors on the back side of the amplifier inside of here that love to go bad over time. And as they go bad, they filter less and less DC voltage from the amplifier circuit before the audio is sent to your subwoofer. And you don't want DC voltage on your speaker. That's what kills your speaker. It's essentially the same thing as taking this 9-volt DC battery here and sticking it onto your speaker. And you see how the speaker moves and it stays there when I put the battery on? That's going to overheat the voice coil over time and kill it. Now, the amplifier does have a bit of a safety built in, where if it detects around 2 to 3 volts of DC voltage, it will force a death fart and restart itself in an attempt to bring that DC voltage under control. Unfortunately, obviously it can only death fart so many times before so much DC voltage that continues to be applied to that subwoofer eventually kills it, if not other things. So death farts are sort of a major sign that you've got too much DC offset being produced by the amplifier, and you want to get it unplugged from power and fixed ASAP before it kills your subwoofer. With that all said, it's already factory reset, so I'm not sure if it's going to pop for us when we unplug it from power here, but let's go ahead and give it a shot. Oh yeah, that's a pop. Based on how loud that was, I'm going to go ahead and guess that we've got probably around 600 to 700 millivolts of DC voltage being sent to the subwoofer. And I'm willing to bet that that quickly grows to around 2 to 3 volts before, of course, that death fart behavior occurs. So, enough talking. Let's crack it open and see what's going on inside. And what we're going to do before we actually do any repairs on this is we're going to fully disassemble it first, of course. And then we will put some test parts onto our amplifier that will allow us to power it on, connect our subwoofer here to it, which has a connection to our multimeter. And that'll give us an idea, just to confirm that we do indeed have that DC offset issue. Once we confirm that, then we can go ahead and replace those filtering capacitors and anything else that may have been damaged from that DC offset. And then we'll also go ahead and replace the 60 volt 5 amp Schottky barrier diode. It has nothing to do with the DC offset or death farts, but it does tend to short out and cause the most common issue, that is no power. So, let's continue here. We're going to get this display out. I cannot wait to try out that electric screwdriver. I'm going to have to run to Harbor Freight tomorrow or something and see if I can find an adapter that'll let me use my T6 bit here. Or perhaps I can find a full-sized T6 bit that will fit into that screwdriver without any adapters. That's going to really come in handy, especially since it seems we're only going to get busier and busier from here, especially with all the shout outs that we've been getting. And especially as these HomePods start to age, we're only going to start seeing more failures. And I'm sure my hands could really use a little bit of a break. Alright, display is out. Let's stick that adhesive back down. Not sure what was going on with my video stream quality there for the first few minutes. I saw my OBS network status fluctuating pretty wildly, but it seems to have stabilized now, so not going to worry about that unless it continues to jump around everywhere. Okay, what the heck? So that's interesting. I've never seen this before. But yet another mystery straight from the factory. They have tied together another bit of string onto the end of this drawstring here in order to make it a little longer. That's pretty funny. Wow. That is... Why would they bother doing that? Because, like, the amount that you get up to this point, that's more than I've seen them give you in a handful of other HomePods. So why they felt it was so necessary to extend it another few inches by tying a piece of string onto the end of it, that is interesting. And this HomePod's definitely never been opened up before. So it's not like somebody else took this apart and did that. Huh. If you missed yesterday's live stream, we took apart Anna's HomePod. I believe hers was the first one. And we found the plastic retainer ring that holds the tweeter speakers in the bottom. It was completely loose and rattling around. Yet another weird mystery straight from the manufacturer. Not sure who let that slide, but it shouldn't have. And that's just as interesting. Huh. Okay. Enough blabbering. Let's keep going. Let's expose the screws for the top basket here. Get this ribbon cable detached from the basket here before we pry this basket off. We don't want to rip that. And now we begin the pry. Very nice. This one's coming up real easy. That crackling sound you hear is not the plastic cracking, but rather the adhesive that they use to glue this into place, giving up the beans. Wow, that came off too easy. Alright, let's get the subwoofer taken out. Just as a quick side note, if you do happen to crack this top basket here when you're prying it off, it's no big deal. This basket doesn't actually do any sealing or anything to affect the sound of the HomePod whatsoever. So if you end up cracking this on accident, so long as you've got all 4 of your mounting tabs here for the logic board still intact, you're A-okay to reuse this. And you don't need to worry about gluing it back down when you put it back together. It's not going to like rattle itself apart or leak any sort of sound. Out with the woofer. Let's check the condition of it real fast. Alright, voice coil looks to be in great shape. Feels nice and smooth. And it smells like a happy subwoofer. So that woofer is A-okay. Time for the power supply. And last but not least, time to take the amplifier out. Error. YouTube is not receiving enough video to maintain smooth streaming. Come on, man. I pay for 1200 megabytes a second down, or megabits a second down, and 40 megabits a second up. I'm only streaming at 6500 kilobytes a second. And I was streaming for about 10 minutes prior to going live just to make sure everything went smooth. And of course, as soon as I click go live on YouTube, that's when it shits the bed. But we're just gonna have to make do with what we got. Sorry, folks. Alright. Anyways, we've got our amplifier taken out. Let's do a quick visual inspection all around just to make sure there isn't anything obviously broken that needs immediate attention. Everything looks to be in okay order. Alright, so as I said when we were getting started, let's throw some parts onto this amplifier so we can power it on, get it connected to our multimeter, and see if there's DC voltage problems coming out of this amplifier. While we're at it, we can go ahead and see if we can reproduce the death fart behavior live on stream here for you guys. It's pretty easy, and it's actually how I discovered how to actually repair these death farts issues. So we don't have a great connection. Oh, it's because my probes there are shorting out together. There we go. There we go. All right. We've got our multimeter obviously set into DC millivolts mode. YouTube tells me that my stream's current bitrate of 6600 is lower than the recommended bitrate. We recommend that you set a stream bitrate of 4500 kilobytes a second. That makes no sense. Get out of here, YouTube. Your advice makes no sense. Here we've got our power. Let's boot this board up and see what we've got going on. Oh boy. So that means that we're past our 200 millivolt scale here, so we got to turn it up. Oh boy. 500 millivolts and growing. Hey Robert, welcome to the chat. Thanks for letting me know the video quality's fine. That's good to hear. I was a little worried about that. Alright, so let's go ahead and do a little bit of a live demonstration here for you guys. We're going to reproduce these death fart behaviors right here, right now. To do that, we're going to carefully flip this board around. Very good. And then this is how I actually discovered which parts were failing and causing the death fart issue. What I did was I took my heat gun and I focused it all around the board, little bits at a time, until I saw the voltage here spike. And that got me around this area on the board. And then from there, what I did was I took my plastic tool to avoid shorting anything out, and I heated my plastic tool up. And I put that on all the different parts around this area until again I found these 4 capacitors, to be specific, were most reactive to the heat and making this voltage spike. So let's grab our hot air and do a quick death fart demonstration for you guys. This is going to be a little scary. It'll catch you off guard there. So watch this. We can heat up any other part of the board. Nothing happens. And as soon as we get near those caps, it gets out of control. There you go. What do you think of that? So, let's tear these test parts off. and we are going to replace those filtering capacitors, and then we'll also replace that Schottky barrier diode just to prevent that no power issue from happening anytime in the near future. And then we'll retest with our multimeter here to see if we've got our DC offset under control. Ideally, we want to see no more than 50 millivolts of DC going into the subwoofer. Anything at or below 50 millivolts is considered A-OK as far as the general audio industry is concerned. Anything above 50 millivolts is pretty undesirable. It's not until you start reaching around 200 to 300 millivolts where you can actually start causing damage to components. So the result that we were seeing here of around 600 to 700 and quickly growing is definitely no bueno. So let's get that fixed. We will replace those filtering capacitors, and then we'll see if we've got any improvement. Okay, let's get you guys up close. Right in on the action here. And there's our boys. Right here, these four size 1206 capacitors right here. If it's not one, it's more than one of them that tends to go bad. But since there's four of them, and there's no great way of testing them, we'd always just go ahead and replace all four of them with high quality replacements. If you're curious exactly which parts and part numbers I use for my repairs, I've got all that information on my website at the top left of the video there, nixfix.com. If you head over to the common issues section, find your specific issue. I've got steps on how to diagnose and repair it, along with the part numbers, and if I've done a YouTube video on it, I've got a link to a YouTube video as well. Let's get those capacitors replaced. There we go. Old ones are off. Let's grab some new ones. I kind of hate this container because I can't grab as many as I want. There we go. Alright. And then we are going to spruce up the pads on our board here with some fresh low temperature, low melt solder. So that way it's a little easier to get those replacement caps on there. And we also don't have to subject those new capacitors to too much heat. There we go. Let's zoom back in there. Get just a little more flux on there. This is ChipQuick NC191. The NC stands for no clean, So we can be pretty generous with our flux here without worrying about cleaning it all up and causing any damage if we don't do so. This stuff is good magic. I'm going to scoot you guys back because you're in the way. Sorry about that. There we go. Now I can see. Okay. We're going to put a little more flux on there and then reheat them one more time just to be sure they've got a nice quality connection on there. Perfect. So we've got a fresh set of DC filtering capacitors on there. That should take care of our wild DC offset issue that was causing our death farts. Before we go and test, we're going to replace the Schottky barrier diode on the other side of the amp here. Just to make sure they don't run into that pesky, oh so common no power issue anytime in the near future. Or as my dentist would say about my crown filling, or my new crown, for many years to come. I was kind of hoping my crown would last my whole lifetime, but I guess they only expect it to last for many years. There we go. Let's put that into our used pile. We keep two separate piles for our diodes that we pull off of all of the HomePod boards. We've got a used pile whenever we replace it, just as sort of preventative maintenance, and then we've got our completely dead pile from the ones that actually come in after they've died. And we're going to break out a brand new diode and get that prepared and put onto our board. go. Let's give this board just a sec to cool down. Obviously, since, as you guys saw when we demonstrated the death fart behavior, heat will affect those capacitors' ability to remove that DC voltage. Good, even if they're still good. So we want to make sure this is nice and cool before we do our tests again. So we'll just stick it in front of our fan here for about 30 seconds and then we'll give it a test. Alright, that should do it. Let's put some parts on here and see what we've got. Logic board, subwoofer, power connector. Get our multimeter turned on, and let's give it a go. It's only 6 o'clock and I'm ready for bed. Alright, what do we got? Incredible. Let's let that settle down for just a sec here. Very nice. So it looks like we're probably going to settle down at around one-ish millivolt, which actually looks like it's going to stay at around 0 millivolts flat there. That is incredible. You couldn't ask for a better result than that. So with our DC voltage filtered out now, we shouldn't see any more death farts. And we've got a new power diode on there, which should prevent the common no power issue from occurring for a very long time on this thing. So let's get it put back together, and then we'll move on to the next HomePod. Excuse me. Get you guys up close. Get in on the action. power supply. Then our retaining rings. Gasket for the logic cable. And then our subwoofer. Excellent. Let's screw the top basket down. It's these screws that makes me really excited to try that electronic screwdriver that Jim sent us. Oof. Makes your hands cramp up. Alright, we're going to put the other one in first because of that weird knot that the factory put into that. Here we go. Alright, the final piece. Here we go. Get some of that adhesive removed from the underside of these volume buttons here, otherwise they won't light up nice and even. And we're just going to heat this bit up real fast so that adhesive gets nice and sticky again. All right. What do we got here? Let's do some sanity checks. It sounds beautiful, and without setting it up I can't actually check the volume buttons, but the setup takes a few minutes, so we'll go ahead and do the setup process after the stream here just to make sure everything is in good working order. But I didn't hear any significant popping, if any, before it played the startup sound. So for all intents and purposes, this HomePod appears to be fixed and ready to rock again. Wow, that stayed on for a long time. Fun. Alright, Jim, or James, or whichever one you are. I'm going to go ahead with Jim since that's what's in your note and our email correspondence. Thank you again for that electric screwdriver. I'm going to get my hands on a full-sized T6 Torx bit so that I can pop it in there and hopefully try it on some HomePod repairs here soon. That is, I really don't know what to say. That's really nice. Thank you. Okay, so up next is John's HomePod with no power. So let's get the text updated on the screen there. All right. Come here, Mr. John HomePod. Let's get rid of that power cable. And hook it up to our power cable that's connected to our watt meter here. Now, with no power, there's a few ways you can, there's one way that you can really tell, or at least take an educated guess as to what's causing your no power issue. And that's by the power draw that you can see at the wall. I've got a kilowatt meter here connected to our power cable. So let's plug it in and just confirm the symptoms reported here. Alright, yes indeed, we've got no power whatsoever. And if we take a look at our power draw on our meter here, we've got about 3 watts. So if we saw a really low power draw, like 1 watt of power being drawn, then that would most likely be a short on the logic board. If we see around 3 to 6 watts of power draw at the wall, then that's more likely going to be the common no power failure, which is the Schottky barrier diode shorting out on the amplifier. And then if we saw no power being drawn at the wall, that would indicate to us that the fuse in the power supply has blown open and it's not completing any circuit whatsoever. So given that we see about 3 watts of power draw at the wall, I'm going to go ahead and take a guess, and also based on experience and how many we've had of these come in, we've most likely got the common shorted Schottky barrier diode on the amplifier. But enough guessing, let's crack it open and find out. When we're removing this top plastic cover here, we're not using our tools to pry it off. Instead, what we're doing is we're going around a few times until the adhesive's fully cut through, and the top should pretty much just pop right off if you've done it enough. That should prevent you from scratching up the bottom of it too much, and it'll prevent you from cracking it trying to lift it up. So again, with our T6, the only size bit you need for almost every single screw in this HomePod. The only different size screw that they use here is on the bottom. If you peel the rubber foot off of the bottom, underneath here, you'll actually find T5 Torx screws, and it holds the mesh onto the bottom of the HomePod. So if you want to do a mesh replacement, or you want to remove your mesh for any reason, that's the only time you're going to need to break out anything other than the T6 screwdriver. But for everything else, if you're going from the top in, everything on the top and everything inside is all the same T6 screwdriver. Surprisingly, Apple kept it pretty simple there. And then I like to use the plastic tool to pry this display up because it sits inside of this plastic frame, and we're also prying in between that plastic frame and our PCB for the display here. And if we use our metal tool to pry this off, we risk scratching and damaging this PCB. So we're going to use our plastic tool for that. There we go. And if you noticed, I only stuck it in about that much. And there's a bit of a dent underneath the display here. And that's quite curious. I've seen this quite a few times. And, well, I mean, if I'm only sticking my tool in this far, there's no way it's my tool that's putting a dent in this. So I can only presume from the factory, yet again, another from the factory mystery here, they're putting in parts that have bits of damage here and there. Quite curious. But usually the dents in here don't cause any problems, so we don't worry about it. And then time to get this frame pulled out. logic board. Then we can pull our mesh down, expose these screws for the top basket. And then we're going to detach our logic board cable here before we forget. Then we can take these screws out and then pry this basket off. Who there? Oh. It's my phone letting me know that Microsoft successfully charged my card. Excellent. Okay, it's time for the pry. Seems to be coming up all right. Not the easiest, but definitely not the most difficult. Oh yeah, there we go. It's giving it up. Okay. There we go. I want to get that extra adhesive removed so that when we put this back together, it doesn't interfere with this sitting nice and flush. Now we can take our subwoofer out. We can peek the condition of our voice coil. It looks great. Feels nice and smooth. And it smells good. So that is a happy subwoofer. Always check your subwoofer if you can. Then our power supply. get our hooker here and use that to pull this straight up and out, so we avoid damaging that connector underneath that plugs into the power or the amplifier right underneath it. Disconnect that ribbon cable for the main logic board. And then 14 screws for the amplifier. All over the place today. Had a long day at the at my day job, and then went and visited the dentist and got some fillings and a crown put in. Got home and started putting my 1986 Nissan 300ZX back together after I blew its head gasket. And we've got 5 HomePods now to fix. So it's been quite a day. And we're not quite close to done. But that's okay. That's good. I like to keep busy. And I mean, if you don't have 3 jobs, what are you doing with your time, eh? Let's see. So, let's get you guys up close so we can do a quick diagnosis. We're going to jump straight towards that Schottky barrier diode right here. Like I mentioned with the previous HomePod that we just fixed up for death farts, we replaced that diode for preventative maintenance, and in this case, this one's already blown up on us, most likely. So let's get our multimeter. We're going to stick that into continuity test mode. So basically when it detects a continuity, or in this case a short, our multimeter is going to beep at us. And then we're going to take either of our probes and stick one of them on the big pin on the bottom, and then we're going to test either pin on the top of the diode here. If this diode is good, we shouldn't hear a beep, and this diode should not show continuity through. If this diode is bad, then it's going to beep at us with the multimeter indicating that it is shorting itself out, or that it is the source of our short. And sure enough, that diode is shorted. Now, obviously that's not in the general electronics world. That's not the true telltale sign that this specific component is shorted out. It could very well be that the short is coming from something else, and the short is also shorting our diode out. But based on our experience and all of the failures that we've seen so far, this diode is almost always the one that's shorted out and causing our no power issues. So let's get it pulled off, and then we'll replace it with a new one. If we weren't very experienced with these repairs, I would suggest after you remove the diode to confirm with the diode removed from the board that the diode by itself is showing the short, and that your short isn't still on the board after you remove this diode. But again, based on our experience and the symptoms that we saw here, we can pretty much confidently say that that is the source of the short and it needs to be replaced. So let's get it pulled off, and we'll replace it with a new one, and then we will see if our amplifier power's on, and we're going to connect our multimeter to the subwoofer to check it for any DC offset issues while we've got it apart before we throw it back together. And there we go. We'll put that into the dead pile. Grab a new diode. Flip that around. Get some flux on there. Then we're going to tin the pads on our diode with some fresh solder. Put some flux onto the board. Place our diode. And then heat that into place. Don't gotta worry about it being perfectly lined up. Once that solder melts, it's gonna suck that diode into place, lined up relatively well. And then we can just push down on it a few times to make sure that everything's got a nice solid connection. See that? See it move? Like magic. See how I push it down and then when I let go it kind of moves itself back into place there? Pretty much does all the hard work for you. I see a little bit of a blob on the corner there. Let's get that out of there so we don't cause any unintentional shorts. And that's all there is to it. So, let's cool this board off for just a second and then we will test it for power and see if it's got any DC offset issues as well. Power supply. Screws for the power supply so it doesn't pop out on us. Subwoofer, power connector, logic board, multimeter, get that set into DC mode, connect that to our probes. And let's see what we've got. We got power. Very nice. We'll of course wait for that to boot up and then we'll check it for DC offset. What do we got? We've got a very chill result here of around 2 to 3 millivolts of DC offset. That is perfectly acceptable. Anything below 10 millivolts is what I call a perfect score. Anything below 50 millivolts really though is the target. So this is all ready to go. Let's take these test parts off and put it back together. our HomePod shell. Let's drop the amplifier in. Put the 14 screws back in for that. Power supply. Oh, let's get that logic cable reconnected down there first. There we go. Now our power supply. Hey John, welcome to the chat. Thank you for joining the stream. Let's get our retainer rings put in. Make sure our glue on this here looks kinda sus. Alright, I'm happy with that. And then our subwoofer. Top basket, top kick, oh, my knuckles. Let's get that screwed in. Peabody. Then our logic board. Excuse me. Logic board frame. Scoot that mesh up and put the screw covers back in. There we go. Alright, the final piece. Put this down and we'll give it a quick test. All right, let's see what we've got. Drum roll, please. We got power. While this is booting up, I'm gonna go grab something to drink. Warm water. All right. Do we got the good sound?
I'm having trouble connecting to the internet.
Yes, we do.
I'm having...
And our volume buttons light up nice and evenly. So John's HomePod is all fixed up and ready to go back home. Let's set that into the box. And we will break out repair number 3 from Chris with no bass. Here we go. Let's get our text updated on the screen there. Make sure the other one looks good. There we go. Let's get this opened up. Oh, that is in beautiful condition. Let's get rid of that power cable. And let's check our symptoms here. So they say it's got no bass. Let's plug it in and power it up. And
I'm having trouble connecting to the internet.
oh yeah,
For more info, check the Home app.
she's missing her bassy voiceness. Let's tear it apart and see what's going on inside. Do we have a blown subwoofer from too much DC offset? Do we have a short on the amplifier? We'll find out. And we'll get it fixed up either way. top is off. Get the display. Let's do a quick push test on the subwoofer here to see if we can feel if the subwoofer's dead or not. No, subwoofer feels nice and smooth, so I'm expecting that to be fine. That's good news for Chris here, because if we don't have to replace the bass speaker, then that makes his repairs just a little cheaper. Buddy, what are you doing? Where's that atlas? Cats are scratching on the walls. Let's get this basket pried off. Oh, it's coming up nice. I think it's ready. Oh, too easy. Lovely. Let's get that subwoofer taken out. Now, just because when we push down on it, it feels smooth, doesn't necessarily mean the bass speaker is guaranteed to be good. But it is a good indicator. But once we get it pulled out, we can do a quick visual inspection of it. Alright, what do we got? We got a happy looking voice coil in there. It's got a nice copper color to it still. And out of the HomePod, it still feels nice and smooth. And it still smells great. So that is a happy subwoofer. That means most likely our issue resides on the amplifier. Let's get this power supply taken out. Disconnect the ribbon cable from the logic board into the amp. And then 14 screws for that amplifier. There we go. Let's see what we've got going on here. Everything looks okay on this side. Let's flip it around. Everything looks okay on this side. So, based on our experience, it's probably not the amplifier chip itself, but we've probably got a short on this capacitor right here, this teeny tiny little black one. I think it is a 29 microfarad capacitor or something like that. Luckily, when this one goes bad, it shorts out and it's pretty easy to test. So let's get up close for that. Switch our cameras, grab our multimeter. We're going going to switch that into continuity test mode again so we can detect if there's any shorts. And then we're going to make sure that our ground to ground is continuity. Very good. So our ground is good. And then we're going to test this tiny little capacitor right here. So that's expected. I believe this is ground. And, oh boy, we found it. This bad boy is shorted. Right here. So, I think I have another one already pulled off in my parts pile here. Let me grab that and check if it's good. Right there. And then we're going to test that with our multimeter here and check and make sure this one is actually good still. Ah, drats. That one's bad too. So we'll put that in the dead pile. And let's find ourselves an amplifier board that we've got set aside for parts. And let's test that capacitor on here and see if it's good. And if so, we can pull it off and replace this dead capacitor on here. And awesome. So this capacitor on our parts board here is still good. Let's see if you guys can see me test it. Awesome. So that's still good. Let's go ahead and pull this dead capacitor off our board here. Replace it with the good capacitor from our parts board here. And that should fix our no base issue. There we go. We can put that parts board off to the side now. Bring our board for repair back into view here. Get that old capacitor pulled off and replaced with this good one. There we go. Let's just double check with that off the board that that is where our short was coming from. Yes, indeed. And then if we double check our good one, our good one is not shorted out. So that's great. Let's put that into the dead pile. Put some flux on our board here, and we'll put this good capacitor back on. Excuse me. There we go. That's a little off there. I don't like that. Let's try again. There we go. I like that. I can dig that. Is that on there nice and solid? Appears to be. Let's double check. We've got good ground, and we've got a good reading on the other pin there. Perfect. Alright, so that should fix the no base issue. One other thing I want to go ahead and replace while we've got this warmed up here is that Drasky, I don't know. Insert insulting term here to name this diode. Let's get this diode replaced. Right there. It's got the Devil's Date code on there, 1748K. We don't want to leave that on there because for all we know, in a few months this could short out and cause them no power issues. Doesn't have anything to do with their no base issue, but this thing shorts out so often that we just go ahead and replace it in every single repair, regardless of what the HomePod's coming in for otherwise. It's also looking a little hot. Like it's got a little bit of a heat spot on there too, so it looks like it's already been running pretty hard. There we go. We'll stick that into the used pile. Grab a new diode. Get that prepped for installation. We're going to put some flux on there and then some fresh solder. Alright, let's go. Look at that big ball. Let's get rid of that. Beautiful. Alright, so that should do it for fixes on this board. Assuming it doesn't have, it doesn't also have any DC offset issues. Let's go ahead and power it on the test bench here. See if we've got our base back. And we'll go from there. I'm going to give it a few seconds in front of the fan here to cool down just for good measure. That should do. Alright, power supply. Ribbon cable for the logic board. Logic board. Subwoofer, so we can see if the bass works and if we've got any DC offset issues. Power connector and power. Oh, before I forget, let's set our meter to DC millivolts mode. Connect that to our subwoofer. We always check for DC offset. Again, regardless of what the HomePod comes in for. You never know if it's got early signs of DC offset issues. So, let's get it powered on. See what we got. What do we got? Ooh, did you hear Siri? She was talking. Amazing. Sure, here's the station picked just for you. Give me the bass. Yeah. Amazing. We got our bass back, boys. And only about 7 millivolts of DC offset. That is a perfectly acceptable score there. We've got this HomePod all fixed up and good to go. Let's get it put back together. I wonder if Content ID is able to Content ID match copyrighted music through just the bass speaker itself. I could argue that that's fair use and to not sue me or demonetize my videos. Not that we're monetized yet, but that'd be nice. Let's put the amplifier back in. Put the 14 screws holding that in. Looks like we've got a few new viewers recently hopping in, so I'll give you guys just a quick update. We just finished repairs on Chris's HomePod here with no bass. The subwoofer was fine, the amplifier chip was fine, but rather what we found was what seems to be starting to be a more common thing, really. There was a tiny little black capacitor underneath the amplifier here that shorted itself out and caused our no bass issues. So we got that capacitor replaced. We also replaced the Schottky barrier diode that loves to fail and cause no power issues, just for good measure. And we've only got 7 millivolts of DC offset on this amplifier, so it's all good to go, and we're just putting this back together now. Get that ribbon cable reinstalled. Drop in our power supply. And then after this HomePod, we've got 2 HomePods from Nathan, both with no power issues. If you're curious exactly about that capacitor that I replaced, I've got some better quality photos up on my website, nixfix.com. Go to the common issues section and scroll down until you find the no bass issues. And I've got a little section about specifically that little black capacitor shorting out and causing no bass. Starting to see more and more of those show up here. So I'm going to need to find the exact specs of that capacitor so I can stop pulling them off of my parts boards and just order a bunch of replacements. And also so other people know, because I'm sure most people don't have broken amplifier or broken HomePod amplifiers sitting around to harvest parts off of. So we'll try to figure out exactly what part you can use to replace that with, and I'll update the information on my website. But the good news is that Chris's subwoofer was still good, so I'm happy. Let's get our subwoofer put back in. We are just a few minutes away from wrapping up this HomePod and moving on to Nathan's HomePods here. Put that top basket in. Oh, lovely. I love when they just sit nice and flush with no interference. You want this basket to be able to sit flush with the shell underneath it without needing to put the screws in, so that way it's not pushing down on the rings below it and causing issues with its sealing. You don't want to rely on the screws holding it flush. You want it to sit flush by itself. You also don't want to over tighten these screws specifically, because that can also mess with your rings and gaskets below, cause your base to get leaky. It'll sound dirty and rattly and all sorts of bad times. Let's cover those screws up. Get our logic board in. Alright, here we go. Let's get that top cover stuck down nice and good. And I think we are ready to test. Let's see what we've got. Drum roll, please. All right, so we put it together right. It's powering on. We'll wait for it to boot up, and then we'll bring up Siri, which will let us hear if the bass is working, and then we'll check if the volume buttons light up nice and evenly as well. All right, what do we got?
I'm having trouble connecting to the internet.
Yes!
For more info, check the Home app.
We've got nice bassy Siri voice. And then do our volume buttons light up nice and even? Yes, they do. So we've got Chris's no bass issue fixed up. Let's set that to the side. And we'll move on to Nathan's 2 HomePods without power. Let's get that text on the screen updated there. Hey Chris, welcome to the chat. Glad you could join us, and I'm glad that you can watch us get your HomePod fixed up and the bass restored. And it's my pleasure to get it fixed up for you. I always love a good fix. Alright, so we've got Nathan's first of 2 HomePods here with no power. Let's go ahead and double check our symptoms here real quick. We want to see just to make sure that it doesn't power on and how much power it's drawing from the wall here. Alright, so yes indeed, we've got no signs of life. And same thing as the first HomePod that we had, I believe with no power. We've got about 3 to 4 watts of power being drawn at the wall. So based on that, we can take an educated guess that we've got a shorted Schottky barrier diode on the amplifier board. So let's crack it open and see what's going on inside. Got the top off. Let's get this display out. Yeah, knock it off. Hey, I said quit it. Where did my big black pick though. That's okay, we'll use this one. Very nice. Frame out, logic board out. Let's get that mesh off. Remove this ribbon cable. Expose our basket screws. Remove those basket screws. And now we pry. Oh yeah. Oh yeah. That came up too easy. Look at that. Let's get the subwoofer out. All right, woofer check. Voice coil looks good. It feels nice and smooth, and it smells good. So that is a happy subwoofer. things out. Let's remove the gasket for the logic cable so when we reassemble it's a little easier for us. We'll get the power supply out. Disconnect the ribbon cable from the amplifier and take those 14 screws out so we can pull that amp out. Wow, USPS is out late tonight. They just dropped off a package. And it's 8 o'clock right now, my time. Out with the amplifier. That diode looks pretty roasty. Yep, it's dead. Let's replace it. Into the dead pile you go. Let's grab a new one. Get it prepped. You get into place. Don't play games with me. There we go. That's all there should be to it. Let's give it a test. See if it powers on without an issue. Oh no. Looks like that resistor popped off on the bottom there. Let's get that put back on. or sorry, capacitor. There we go. Cool this off real fast and we'll give it a test. All right. Power supply. Logic cable. Subwoofer. Power connector. Logic board. And last but not least, power. Very nice. First HomePod no power repair for Nathan now has power. So I just connected our multimeter to the subwoofer here so we can see if it's got any DC offset issues as well. We don't want to send it back knowing that that's got a problem too. What do we got? Oh, couldn't ask for much better. We're sitting at around 1 to 2 millivolts of DC offset. So that is an excellent score. I can hear the bass working, and this one looks to be all ready to go. So let's throw it back together, and then we can move on to Nathan's second HomePod. Looks like a few people are still watching. I'm a little surprised we're like 2.5 hours into our repair stream here. Good on you, mates. Thank you for sticking around. $14 screws for the amp. Who dat? It's a Discord message. amplifier in. Let's reconnect the ribbon cable going into it. And then our power supply. Retainer rings. Gasket for this ribbon cable. Don't want to forget that. We'll have some very dirty sounding bass. Subwoofer. Top basket. Let's screw that down. logic board. Frame. Let's cover up those screws for the basket. Alright, time for the finishing touches. please. Yeah, we got power.
I'm having trouble connecting to the internet. I'm having trouble.
Very nice. Everything checks out for this first HomePod from Nathan. Let's put it in the box and move on to their second one here. Our last HomePod for the repair stream today. Yep, no life. 4 watts of power draw at the wall. Probably the same thing as his last one. I'm going to go into quiet mode here and try to speed through this last repair so we can have the rest of our night off. The bride. Baba Booey. Any DC offset? Oh, wonderful. Thank you for supporting my speed run. time. We started this HomePod at 8:20 and we just finished at 8:43, so that's about 23 minutes to fix this bad boy. Go ahead and try to beat that. None of it matters if it doesn't work, though.
I'm having trouble connecting to the
Oh,
internet.
yeah. Everything checks out. Well, that might just be a world record for time to repair a HomePod. What do you think? Wow. All right, folks. We got all 5 HomePods fixed up today without any major surprises or issues. If you have any questions about any of the repairs that I do on HomePods or anything in general, feel free to drop down a comment below. I also suggest you check out my website at nixfix.com at the top left there. I've got a whole bunch of resources if you want to repair your own HomePod. Check out the common issues section where I've got steps to diagnose and repair those issues as well as the parts that you need to do so. Or if you'd rather mail it in for repair, I've got my contact info up there as well. Hope you all enjoyed this live stream repair and this record-breaking HomePod repair speed run, and I'll catch you all in the next one. Goodbye!